I did you get my email?
I didn't get your email.
Because the Google Driver one lets me and to ask me to get permission.
Permission to do what? To upload.
Like to access the files that you uploaded.
Yeah, I didn't remove your. I authorized you once. I didn't remove the authorization. Maybe we're gonna study that during break time.
Okay.
We're gonna
Because
study.
it's for me, it's gonna be really helpful if you do it now, brother. Because so I can see the material.
Yeah, the materials I'm gonna share will be from Canvas, from Professor Chatterjee. It's not from Google Drive. Yeah.
And how I get them?
You may not be able to get them until when you take this course, you will have them. So because you have not taken them, so you're not gonna like you don't want to like spend so much time because this class, like I explained earlier on, is for mainly for those who are preparing for this exam this next semester. So when you take this course, you're gonna get some of these slides. So I'm not gonna download all the things from Canvas. It will come up in parts and patches. So I'm not be able to organize it very well. So it's better viewed from Canvas. So this video recording will help you also, to view the slides and then pause when you want to study on your own. So welcome guys. I heard over the news today that Elon Musk finally bought over Twitter. Do you think that's gonna be a kind of an impact in the way people use Twitter? What do you think about it? Is there going to be some changes? Like he claims there's going to be free speech. What does he mean by free speech? Is it possible to really enforce
Is he going
that?
to bring Trump back?
Huh?
Is he going to bring Trump back on Twitter? Because Trump is banned from Twitter.
I'm sure it's going to happen. Yeah, I'm sure it's going to happen, But the problem is, what do you mean by free speech? Is it bullying people or whatever over the platforms? I don't know. But the man is like creating new waves every day, buying over. Someday he's going to buy over buy the whole. Already he's richer than some countries in Africa. So yeah, so guys, today we are starting with design science research. I know, Amrik, you have taken this course.
Yes.
Amira, you have taken this course. Ted, you have taken this course. It will be my pleasure if you would come on video so that at least this become interactive. I'm talking to my TV, not seeing any of you. Please, if it's possible for you to come online. This is a PR, stuff. Someone is behind the steering.
I am.
Yeah. Clement, sorry, my internet sucks. So if I turn on the video, it's gonna disconnect.
Yeah, I've not been able to hear from Ted. Ted, if you are there, please come on video. Nobody.
Yeah, my internet also. Yeah, same situation.
Okay.
I will try to use that better.
Yeah. So before I start sharing, I would want us to first of all discuss in general, about DSR. We discuss in general, and then we look at the slides again to Professor Chatterjee's slides. We're not gonna go through everything on his slide, because I want us to be a bit fast now because the semester is coming to an end, and it's high time we started reviewing past questions. But first of all, let us, arm ourselves with the knowledge we need to tackle the more difficult problems. So before I start sharing the slide, we are discussing about design science research, which is a paradigm, a methodological paradigm, a scientific paradigm, for doing information systems. Our goal as information system researchers is to understand how people use technology and how we can, help them to create more value in their use of technology. Design science research as a paradigm, in IX, focuses on designing, building, and evaluating artifacts, technological artifacts, not just designing any stuff, technological artifacts to solve organizational problem. What it means that it solves a problem within a context, not just a general problem. It has to be a specific problem identified within a context, an organizational context. And then the design science researcher, tries to understand the problem and proposes, a technological artifact to solve that problem. The artifact may be an instantiation, a product, maybe like this remote. It could also be a new algorithm. It could also be a new method. It could also be a framework to understand things better. But then, what kind of problem does DSR tries to solve? Is it any kind of problem? Because it is a design science. And we say that design is both a product and also a process. Product and a process is a accumulation of several iterative activities, a process that finally culminates in a designed product. But there is a difference between, because every day we see people designing, coming up with new stuff on the market. We have to distinguish between routine design and design science. One, design science is a research methodology, which means it aims to solve a problem while making a contribution to knowledge. So it follows that systematic approach of doing research. But the difference lies in their approach and their solution. Usually, routine design is taking, what is already there, the best artifacts already, that has already been designed, the best practices, that is already there in the knowledge base. You use it and then apply it to solve a problem. Taking what is already there, best practices, best artifacts, best methodologies, best frameworks, best instantiation, using them to solve a problem. That is routine design. Most designs products we see in the market might have used one or two, approaches based on the best practices to design the artifact. But design science research tries to solve hitherto unsolved problems in a very unique and innovative way. Unsolved problems. Sometimes we call these problems wicked problems. Wicked because there is no existing solution anywhere. And wicked because they rely on human intellect, creativity, rationality, intuition to solve these problems. So unique problems in an innovative way, hitherto unsolved problems in a very unique and innovative way, or solving already solved problems in a more efficient and effective manner. That is an improvement on what is already there. And one thing about design science is it focuses on building and evaluation of artifacts. And that evaluation is a way of proving the worth of the artifact a way of demonstrating through empirical evidence that this artifact really works. Utility is what we are evaluating. We also evaluate performance, usability, to show that the problem was actually solved through the instantiation of the artifact. Design science focuses on building and evaluation. And as a different paradigm in the IX, the rest of the IX focuses on maybe human and organizational reality, like the Utah. Most of the models we have are, predictive models that have strong background or strong roots on psychology, studying human behavior as humans interact with the organizational systems, and also the phenomenon that emerges in this interaction. There is a kind of prescriptive and a descriptive aspect of IX. The descriptive aspect of IX is where the kernel theories that tries to justify, to develop and justify new theories. And these theories are usually, helps us to better understand human behavior as they interact with organizational systems. But DXR, as a different paradigm in doing IX, as a methodology, focuses on building and evaluation of artifacts. It uses already existing validated theories. That's why there is emphasis on kernel theories in doing DSR. Very, very important. An emphasis on kernel theories. There is this problem of, the theory fetishism, and the theory is king in IX, theory is everything, If you are doing a qualifying exam, usually you expect that they are going to present you a wicked problem. Usually it is always a wicked problem in, during the qual exams. And when you are presented with this wicked problem, you will always mention a kernel theory, that you will use a kernel theory. Even though at that point in time, you may not be able to find an existing theory, but it is good you mention during the exam that I will find an appropriate kernel theories. Why do we use kernel theories? When we reviewed is it Shelley Gregor and theories in information system, the last theory there she listed out was the design science theory. And design science theories are meant to be prescriptive theories that prescribes, a rule of action of how things are to be done. Other theories, prediction, explanation, tries to explain phenomenon to help us to understand, phenomenon better. But design science, offers us prescriptive theories that helps us to, prescribe action of how things should be done, of how an artifact should be designed. But unfortunately, we encounter this difficulty of not because of the nature of the wicked problems we face daily, in society and in organizations. Most times it is difficult for you to find a kernel theory that will really give you a prescription. A prescription is like a step-by-step guide of how to design this artifact. And because of the nature of the artifacts we design in IS, it is very hard for you to find a kernel theory that will give you a full prescription of how to design any artifact. It is difficult because of the nature of the wicked problems, we encounter daily. So the importance of theory, or kernel theories in IS could be, offering us insights, inspiration on how the artifact could be designed, not necessarily, giving you prescription. So for instance, one could say, you want to use Utah. Maybe let's say you want to use the concept of the construct of a performance expectancy. Performance expectancy, which defines, that people, let me just use a more appropriate one. A more appropriate one would be effort expectancy. When the use of the system is easy for people, there is the tendency that they are going to adopt the system. Which means, if you are using this construct from youth out as an inspiration, which means you might say you have to design your system to be very usable, maybe have very good interactive, interface, graphic user interface, very friendly graphic user interface. And you drew your inspiration from effort expectancy because you really want both children, adults, anyone, to be able to use this system and interact, with the graphic interface in a very friendly, manner. So your inspiration might have come from effort expectancy. So you don't want the system to be very hard for people who are not tech savvy. So you see how the youth out, gives you a kind of inspiration. There could be other theories out there that gives you inspiration. So there is always emphasis on kernel theories. There could also be other kernel theories, that provides insight or gives you some kind of prescription in designing an artifact. And do you know why there is emphasis on theories, even in designing, artifact? Because the knowledge contribution you are going to make could be an extension. When you are evaluating the artifact, you are also a kind of evaluating the theoretical principles that formed, that artifact. We talk about design principles. There is a collection of principles that, drawn from kernel theories that informs the artifact design, which means the artifact is an embodiment of a whole lot of principles coming from several theories or different theories or from the knowledge base. So all these principles, when evaluated in depth, could even give rise to a design theory. So every artifact embodies the kernel principles from kernel theories. When you're evaluating the artifact, you are kind of evaluating also the theory that forms the basis of that artifact. If you don't have a theoretical background, yes, Professor Chatterjee made it very clear, we must not sacrifice creativity, for this quest, for theories. People are still, but for qual exam, mention that you are going to find a good theory that informs the artifact design, even though in principle, we cannot sacrifice creativity. So if you are able to demonstrate the artifact works, even though there is no kernel theory, it still stands because the solution has been offered and demonstrated. You understand? So Professor Chatterjee will always mention creativity is a very important aspect of design science research. So I'm trying to give a general and holistic view of design science. So there are three cycles in design science. 3 cycles. The first cycle is the environment. The center of the cycle, we are going to shift most of these slides. I want us to summarize this in first, and then when we see the slides, it will make more sense. At the middle of that cycle is where you design and evaluate. And then, so we have the relevance cycle. The relevance cycle is the organizational environment where you meet the people, the technical artifacts, or the socio-technical artifacts.
Clement, did you say you have slides?
Hello?
Did you say you have slides?
Yes.
Wouldn't it be better if you're explaining?
We are giving a general overview. Remember, this is a whole semester course that we want to put together in 1 or 2 weeks. So I presume that most of us have taken this class. So I'm giving like a general overview, then I will share the slides. When I share the slides, we'll be a bit faster, So anyway, but if you insist, let me begin sharing the slides now. Let me begin sharing the slides. So, So I've already mentioned that, okay, let me start sharing now. Okay, share the screen. Okay. Okay, so this is Professor Chatterjee's slide. I've explained the beginning, most of the importance, most of these things have been explained already. The research, the context, prescriptive and descriptive. The natural sciences are more of prescriptive, tries to understand the nature of the artifact, where prescriptive is design science, tries improving the performance. So the science of the artificial, because when in design science, we design and we create artificial things. And this man tries to explain in his book, what the science of artificial, what it means for something that exists in nature and something that is man-made. So when we talk about artifact, we're talking about a creation, a construct of man, The behavioral sciences tries to develop theories justified through data collection experimentation. In DSR, what we do is we build and we evaluate. We have many ways of evaluating: analytical, instantiation, experimentation, measurement. So we shall come to those in details. So the ongoing debate in us is between engineering and physical sciences. So why pure sciences normally have upper hand in such debates? Because pure sciences have already well demonstrated ways of evaluating and building, well demonstrated ways of justifying theories. It is not so much like in IX. We don't have that kind of kernel theories that provides a kind of holistic and marginalized understanding of phenomena. So there's kind of still a serious controversy, So the natural sciences, they seek truth, trying to discover, discovery and justification. Design science is building and evaluation. So Nunameka and Briggs. Nunameka is the founder of, among the father founders of IX, understand? I remember his popular comment. He says that we shouldn't be just historians of information systems, but rather we should also design, artifact. We have to make an impact in practice. So that we are able to give us a deeper understanding of the what DSR, where it stands in IX. So the formalized, proposed and the formalized what DSR means, and then in IX research. So they say that the DSR focuses on the rest of the information system: procedures, hardware, software, and data. So the other side of the information systems, we try to understand human behavior, study predicting human intentions, human behavior in the use of system. We have people, but the DSR takes care of the other parts, the rest, which has to do with procedures, hardware, software, and data. So, and the objects of inquiry of design science are design processes, products, systems. So we already have seen this in the past: building and evaluation. We have already defined what DSR is. Research paradigm answers, designer answers questions relevant to human problems via creation of innovative artifacts contributing to knowledge. The design artifacts are useful for fundamental in understanding the problem. That means you can understand the problem you're trying to solve better in designing the artifact. So look at the outputs. These are the outputs of construct, model, frameworks, methods, algorithm, instantiation, design theories. Usually these design theories was added much later. It wasn't there at the beginning. So we can also come up with design theories, but usually contextual theories that are context bound. It is difficult because of the nature of the problems DSR solves to actually come up with a design theory that has a wider generalizability, like a grand theory. No, so it is like a context-bound kind of theory that we can get in design science, because the problems we are solving is limited to a particular context. Okay, and so the fundamental principle of design science research is that knowledge and understanding of a design problem and its solution are acquired in building and application of the artifact. So what is design? We explain what design is about. A product. It's not just a product, because it is both a product and a process It's an iterative process. You define, ideate, you prototype, you test, and then always empathy. Why designing for people? And then researcher career, government things. These are areas that you can trying to understand the issues, where you can find issues. It can be from the government, it could be academic, it could be industry, creating a startup, independent consultant. And then publishing, So this usually should come, towards the end, and then how you go about publishing your papers. So, and this is the end of this particular one. Like everything I said earlier already is embodied in this first slide. So we go over to the second one. So as I go on, I will emphasize some important things that need to bear in mind when you are answering a DSR question. So usually solving a problem always begins with trying to understand the problem, a deeper understanding the problem. You do a lot of research, you have used a lot of frameworks and models out there, like we have the hackathon, we have the mind mapping, we use, there are different tools out there, the fishbone, to understand, all these are methodologies you can use to understand the problem better, before you start solving, and usually you don't presume what the solution would be, because you have to understand the problem better as you are designing the artifact. So there is always a contribution to knowledge, like I mentioned earlier, when you are doing a design. So it's not just creating an artifact, you have to also make contribution to knowledge. So here we will build and evaluate, and heretofore unsolved problems, and then we evaluate with respect to utility, solving problems. We already mentioned this earlier on, and all these frameworks and methodology are ways to help you to understand better the problem you are trying to solve. Awareness of the problem, suggestion, development, evaluation, and conclusion. So most of these things are not very important for the qual exams. So all these things we already mentioned in the previous slides, and then these are the outputs of DSR, well explained. So constructs provide like language, models, provide a real world situation. Like we all have models. We create models when we are even doing outside the DSR. You need to create model, understand the representation of the real world phenomena you are trying to study, the different relationship between the different constructs, and then which are usually measurable, So, and usually, design science always starts with a problem. You have a problem, you pose a hypothesis. But you try to solve the hypothesis. The solution to your hypothesis lies in the construction of the artifact and evaluating it. So methods and instantiation. Instantiations are usually, kind of a demonstration of the actual working thing, the feasibility, assessment of the artifact's suitability for its intended use. Look at the framework I was talking before. Yeah. So please memorize this framework. Memorize this framework. If you are answering the qualifying exams questions, every question you are going to answer in DSR will be plugged into these different phases, these, three major phases of the research model. First of all, you talk about the environment. The environment, the question most times might already tell you where the problem lies, the organization, what they are encountering. So, but there is always an environment, relevance, like where you identify the problem you want to solve. So there is a problem class, and also a solution space. A problem class is like maybe you are trying to solve a problem relating to human resource management, but the problem you are solving might be employee attrition, or so why you are trying to solve problem, it belongs to a particular class of problem. So in DSR, we talk about class of problem. because your contribution will be to that class. So assuming that you are studying employee attrition, why there are high levels of employee attrition in an industry, it is the problem you want to tackle. But this problem belongs to a class. And the class of the problem might be, the general class might be human resource, So any contribution you're going to make in this specific area, problem you're solving will be related to that class of problems, human, resources management, So you think about people, about their roles, capabilities, and characteristics. I'll think about the organization, because we're always solving problem for a particular organization, the strategies, the structures, the cultures, and the processes. All these things must be, we call it relevance cycle. Relevance cycle because here you have to substantiate that the problem you want to solve is interesting. And it is not solving any type of problem, useless kind of solution. You are solving a problem that is of interest, that will be beneficial. A problem that is
a wicked problem, right?
No, we're not talking about wicked problem now. We're talking about how interesting, this problem, like these people have really, you were able to identify, having studied the people, the organization, and their technology, you have identified that there is a real problem here that needs to be solved. It might be a wicked problem. It might not be a problem that has already, they have had some solutions in the past. Okay. But you as an IS researcher, they want you to provide a more efficient and effective way, to handle the problem. Maybe, an improvement to existing solution, Mm-hmm. So, but the problem, what I'm emphasizing here, that the problem has to be very interesting. They really have a problem and they need a solution to it. So it's not just solving any kind of problem. Maybe you feel it is a problem, whereas it's of no interest to the people working in an organization. So that's why we talk about the relevance. You have to state the relevance of the artifact, because when you have studied the environment, the organization, and the kind of technology infrastructure applications, it could be changing the technological infrastructure, it could be updating, it could be, getting a better algorithm, it could be changing the application, it could be their communication problems or whatever, So you have to identify the problem within the organization, and it has to be very interesting, and it will be a problem that its solution will actually be demonstrated within this organizational environment again, because we are going to come to the evaluate, and you see the arrow line, this line pointing back from evaluate to going back. You are going to evaluate, within the same environment to demonstrate if actually you solved the problem. But if you need to understand the people, the organization, the technology very, very, very well, so that you can propose the best solution. It could be a framework. It could be a construct, new method, new algorithm. It could be even a product, It could be making a contribution to, theory, design theory. So you have to identify what could be the best solution to this problem. That's why you have to study the organizational environment, the business needs. Mohammed, you raised your hand. Okay.
So, what is the role of the qualitative and quantitative in this case?
I'm coming to that place. We shall come to that. Yes.
Oh, okay.
I promise you, I'm going to clarify you. Yeah. So this is the relevance cycle. Show us how relevant this problem is. Identify the business needs of the organization. When you have identified this, you move to the next stage. The next stage is where you do the building, the development, the building and also evaluation of the artifact. But before you build this artifact, you begin to think about theories. What your existing theories, could inform the design of this artifact. We call it the Rigor Cycle. And this rigor cycle interfaces with the knowledge base, which means you are taking something from the knowledge base and also adding something to the knowledge base. You see this line, pointing back to the knowledge base. And you see this green arrow linking to the building and development and evaluation. It's here that we do the actual thing. In this middle phase that we do the actual thing. So you think about if there are existing principles, framework, or construct or models already in the knowledge base that will inform, that will provide design principles for the building of the artifact. When you have taken all this from the knowledge base, then you evaluate it depending on the type of artifact. You might be evaluating usability. You might be demonstrating, because it is all about demonstrating the what. It could be analytical, like when you are doing like a software, you have to analyze the software and know, and you have to demonstrate how this artifact is better than the existing artifact. If it is an improvement contribution. If it is a new problem you are solving in a very innovative way, you have to show that it actually works. It could be like a case study. Now, Mohammed, the question you asked me, and here is where many students usually get it wrong. Many students, when they're asked to propose a DXR research, they propose a quantitative or qualitative approach. We already saw the quantitative and the qualitative approaches to, in IX. And the goal is all about trying to understand the phenomenon, quantitatively or qualitatively. But here, our concern is to build and to demonstrate the utility of what we are building. So we are no longer concerned so much as, trying to understand people and their behavior. That is not the major focus, but it is part of the concern here. But because people also have to inform what you are doing in the design of the artifact. But the major goal here is to provide. If you are not designing something, you are not doing DSR. Professor Monk emphasized that if you read the WhatsApp feedback he gave, if you are not designing something, you are not doing DSR. So where does the quantitative and qualitative approaches come in? They come in the evaluation phase. You can evaluate, look at this experimental. You can use ANOVA. You can use Mancover. You can use multiple regression to evaluate the artifact. And this experimental might be, okay, you have provided a solution, which is this I'm holding now, the remote I'm holding. And then you decide to use ANOVA, which is an experimental, research approach. You have, because since ANOVA focuses on maybe 3 or more groups, or let's say, to be very precise, you use a t-text, which maybe deals with 2 groups only. Then you have this control group, understand, and the experimental group. Now, you ask the experimental group, use this my artifact to do this work. Why the other group do it the usual traditional way? And let's see which group does better. I don't know if I'm making sense. Hello, are you there? Hello, can you hear me?
Yes. But
okay.
Can you repeat, please, if you don't mind?
Yeah. So you now define the 2 groups. Maybe you are using a t-text. If it is a problem that requires like ANOVA, you have 3 groups. You can create those 3 groups and then ask one group to use the existing artifact. And then ask another group to use the new artifact you designed. And ask the other group not to use anything at all. That is, you are using ANOVA. And then you put them through an experiment, a controlled experiment, and then you could be able, at the end of the experiment, to understand whether the group that used the new artifact you designed performed better than the group that didn't use, that used the old existing artifact, or the group that didn't use it at all. Maybe you might need to do, since ANOVA doesn't show you the particular group, you might need to do a follow-up test to understand where the difference actually lies. So that's where you can use experimental. You can also use a field study. Field study, you ask people in the field to use this artifact, and you're able to demonstrate if also contributed to the solution, because what you are evaluating is utility. It could also be performance. It's kind of providing an empirical evidence that this is better than the existing solution, or that this actually solves the problem. And the kernel theory here also comes in, because the kernel theory will also inform the evaluation phase as much as it informs the design phase. So you also use kernel theories in evaluating, because already the kernel theory you are using has already hypothesized relationship with the construct. So while you are evaluating the artifact, you are evaluating the theory. Perhaps maybe the theory says that people do their work, better when they work maybe only 8 hours a day, or within the first 2 hours. They do their work better and more focused. That is what the theory states. And then you are designing this artifact, and you subject the people to use it for only the 2 hours or the 3 hours, which the theory already proposed and have already defined that people work better. So in using the artifact to work for 2 to 3 hours, if they were able to perform more efficiently, then your artifact evaluation agrees with the theory you used that provided the inspiration. Or it could be refute the theory that it doesn't actually work, and then you find out why it didn't work. Perhaps there are some other variables that explains why the artifact being used within the 2 hours the theory proposed, does not actually help people to do their work better. Perhaps maybe you didn't design the correct artifact. In system engineering, which is my background, usually we talk about validation and verification. Validation is ensuring that you build the right system. Building the right system, the system that offers the customer, that serves the customer's needs. And the verification is ensuring that the system meets the required specification, that it will actually build right. So it could be a problem, so evaluation also has to do with the validation and the verification, even in software engineering or in systems engineering. So you can also do simulation. Like if you have a software, you can also run a simulation and then provide concrete evidence, that this algorithm performs better, than that. Usually you need metrics when you are doing evaluation. We are going to come to that, and then we discuss more about that. You have to define the metrics of what you are evaluating. Understand? So the metrics is you're going to evaluate the speed, throughput, load. You have to define what you're actually measuring, and to show maybe that this system can handle like a throughput of maybe 16 gigabytes per second under 1 second. So it is faster than the existing systems. That is like what your simulation, performance evaluation. You have been able to show, judging from speed, which is like would be one metric. You can also use system usability scale, which is like there are already validated metrics out there you can use. They already have survey questions that people can answer. You introduce the system, they are using the artifact, and then you put forward this QUIX, and then ask them to evaluate their use of the artifact based on its usability. It can give you a feedback. And from that feedback, it becomes your evaluation. That people said, maybe 98% of the people said the system was easy for them to use. You already won. You solved the problem, So you take from theories and from the existing foundations and methodologies, and then also you make a contribution to knowledge. And this contribution could be saying that at the end of our evaluation, we're able to show, based on the example I gave earlier on, that working 3 hours actually helped people to perform better, which means the theory was correct. The predictions of the theory, was significant in the use of the artifact. People performed better. And that is what you are contributing again. It could be a contribution in terms of, framework, instrument, concept models. It could be also design principles, or it could be a design theory. So we call this the rigor cycle. Rigor, because here is a rigor. You don't just design anything, You have to show how you did it. This level of transparency is what we need, And the justification, evaluation is not an easy task. It can cost a lot of money, can take a lot of time, to demonstrate the worth of an artifact, to show that it actually, which means if you deploy the artifact within the organization, at the end, and the problem was not solved, which means you have contributed nothing. You've not contributed nothing, which means you might need to go back and see what's the problem. Just like someone collecting data and it wasn't significant, and then it needs to collect more data, to understand why, the research came out, predictions came out in a different way, So that's about this cycle. Please memorize this cycle.
Backtrack a bit. So you said the difference between DSR and let's say quant and qual, basically in DSR you have to design an artifact. You also said something else about in quant and qual you are observing a phenomenon, or what were your exact words? Sorry.
And when we do quantitative research, quantitative and qualitative research, we are mostly studying, studying people within the organization, and we are also studying the phenomenon. Can you hear me?
Yeah.
Yeah. We usually it is the descriptive approach. The quant and the qual are usually the descriptive approach of natural sciences, which tries to predict human behavior, understand human behavior, study phenomenon, It could be social phenomenon, it could be some natural phenomenon related to, the use of technology in an organization. It could be studying human behavior and their interaction. And the goal is to develop and justify theories about the phenomenon. To make a statement of relationship about the phenomenon we are studying. They have no business in building an artifact, designing and evaluating an artifact to solve a problem. But they solve a conceptual. So their problem they solve, quantitative and qualitative, are kind of conceptual problem. Conceptual, giving you a theory, a better understanding of what is going on there, in the people's, in the interaction with them, with the organization. And usually you might ask me, where do we theorize in design science? We shall come to that, one of the slides detailed on that. Human-computer interaction. There is 3 phases of our theorizing. The first level is where we try to understand human behavior, predict human behavior. That is not our area in DSR for a design science researcher. He's not interested in understanding like human behavior, studying the phenomenon within the organization in order to provide, come up with justified theories to explain what is going on there in terms of human interaction within the organization. And then we are not concerned about the technicalities of the artifact or the specification of the artifact, whether this artifact is going to, what kind of semiconductors are we going to use, or what kind of, or what should be the correct ampage, all these technical details, what should be the processor speed, and we are not concerned with that. A design science researcher is concerned about the where humans interact with the computers. So human-computer interaction, HCI. That is where we theorize at the middle. We shall come to that slide, you know. So in DSR, you are building, you are designing, you are evaluating. You are not, if you are not designing something, then you are not doing DSR. So where qualitative and quantitative comes in is you are using those approaches to evaluate the artifact. I don't know.
Yeah. Yeah. Thank you.
Yeah. So please always take me back. You know, we really need to understand most of these things very concretely so that people don't mess it up. Because a lot of, okay, you did, you know, one of the best, you know, when we did with Professor Monk, you know, a lot of students, you know, screwed up during the first, the midterm exams, you know. So I think you have better understanding of most of these concepts and ideas, you know, before now. So Mohammed, you now understand where the qualitative and quantitative, where it comes in DSR. So don't, when you are taking this class, I hope you are going to do better than the rest. So having gone through with us, you know, in this workshop, you are going to do better than the rest. I'll be there then to, you know, see what's going on. So when is IS research useful? You know, theory, a justified theory is not just useful for environment, contributes to, you know, literature, an artifact that solves a problem, a non-existent, okay? You know, there's some of the minor things, yeah. Guidelines, design an artifact, problem relevance, develop theological based solutions, like technological based solutions, you know. So design evaluation, we are looking at the quality, the efficacy, the utility must be rigorously demonstrated via well executed, you know, evaluation methods. Research contribution, what is new, you know, where is the contribution in the area of the design artifact, design foundational design methodologies. And then what's the rigor? You know, design research relies on application of rigorous methods in both construction and evaluation. And most of this rigorous method could be this like experimental, using ANOVA or t-test, or, you know, these are like rigorous ways of demonstrating things. And then design as a search process. Search for an effective artifact requires utilizing available means to reach the design and while satisfying the laws in the problem environment. You know, you're utilizing available, like you're taking from the knowledge base what is already there, you know. And so no matter how unique or novel the artifact is, there has to be something existing in literature that you can pick up, you can lay hands on to start your, you know, creative approach to solving the problem. So communicate well, you know, present effectively both technical and managerial audience, you know. I forgot to mention that evaluation, we do technical and social technical. We shall come to that. So problem relevance, is it new, interesting, and useful? You know, I mentioned that earlier. So it's not just any kind of problem. There must be something, it will be something that's going to be useful. And then evaluation, you know, the utility, quality, and efficacy requires definition of appropriate metrics, you know, possible gathering of appropriate data. Look at it. So it might also be it could be qualitative way of evaluation, which means you are asking people using interview to ask people questions about their use, about their experience with a product. So which means you're using a qualitative approach for the evaluation. But you have to define the metrics, maybe in the kind of questions you ask them. Maybe, did you find this product useful? Did it, maybe in terms of how long did it take you? Were you able to accomplish your work, you know, in little or no time using this artifact? Understand? Was the use of artifact? So the kind of questions you ask in an interview also captures the metrics you are using to evaluate the artifact. Gathering your data could be qualitative or quantitative data. Then IT artifact can be evaluated in terms of functionality, completeness, consistency, accuracy, performance, usability. Depends on like what you are trying to. You are evaluating. Sometimes you are not evaluating for just one person within the organization, you know, because an artifact could have a chain of users, you know. It could be a health artifact. You're evaluating for the patients. You're evaluating for the doctors and the nurses. You're also evaluating for the sponsor. You have to tell the sponsor that this is going to yield you money, and look at it. You know, provide evidence, concrete evidence of how this is going to yield the money. You have to tell the doctors how this is going to make their work more efficient. You have to tell the patients, you know, how this is going to contribute and prolong their health. So all these things. So it could be one evaluation, or it could be multiple evaluations. It could be technical evaluation. You're looking at maybe drop and black box or kind of white box testing to see if the specification we actually met, in terms of what should be the current maybe FDA approved, requirements for designing such an artifact. The technicals are part of it. It could be socio-technical when it has to do with people within an organization. So and then in socio-technical, that's where you can bring in like qualitative approach. You interface people in trying to understand their approach, or the contribution of the artifact to doing their work better. Remember, we're talking about technological artifacts, So a look at evaluation here. It could be observational case study. It could be analytical. It could be experimental, controlled experiment. Study the artifact in the controlled environment for qualities like usability. It could be texting, functional, execute interface to discover failures and defects. Maybe run to see how the software, the artifact performs. Maybe to know if maybe the current is very high, does it fail, or can it just get destroyed by certain circumstances? All these things have to be black box testing. It could be white box testing. It could be descriptive, informed argument, using information from the knowledge base, example, relevant research to build a convincing argument of the artifact utility. You see, you can also use descriptive. You can use scenarios, construct detailed scenarios around the artifact to demonstrate its utility. So you have multiple ways of evaluation. It depends on the people you are evaluating for and what is their priority, So for some people, it might be testing, functional testing is their priority. For some others, descriptive could well serve the purpose, So we already discussed routine design and DSR. I mentioned it earlier. So the difference is in the nature of the problem and solution. So routine design is applying what is known, to organizational problems using best practice artifacts in the knowledge base. Example, constructing a financial or marketing. But design science is on solve the problem in a very unique, innovative way, or solve problem in a more effective and efficient. Where is the novelty? That's the question. Does it add new knowledge to the base? The key is to clearly identify a contribution to archival knowledge base of foundations and methodologies. That is where usually the problem is. You can design the artifact, it solves the problem, but there is no contribution to knowledge. That's why theory is important. All these things are some other details that are not so much important. Design as a composite idea of doing innovative design that results in clear contribution to knowledge, yes. Researching design should the focus of the study to designers and design processes. The community studies design methods are able to generate domain-independent processes. Okay. Now, this chart explains better what we described earlier. The relevance requirement, field texting, revolves around the application domain and then the building and the design cycle. So the rigor cycle also, you take from here and you add. So that's it. You're taking from here, you add into here. Here you are iterating as you are designing and then evaluating, so it's an iterative cycle. That's why design is a process, continuous iteration, and you get the final product. So remember the relevance cycle, the design cycle, and the rigor cycle. Grounding and addition to knowledge base. Grounded in knowledge base, additions to knowledge base. You understand what that means already, So it has to be grounded in some theories and some processes or some existing methodologies, and then come up with new contribution. So always mention. So in a qual exam, they will propose an artifact, a wicked problem, and ask you to solve the problem. First of all, you describe how you are going to try to understand the problem better, and maybe how you're going to implement. We're going to talk about PFAS. PFAS, a process, 7 processes, 7 steps in understanding a problem. We're going to come across it here. So the first of all is demonstration, design, demonstration, evaluation. So we are going to see the 7 steps, or PFAS 7 steps. Usually that's the first thing you begin with. And then so you're understanding the problem. And this falls within the application environment. Having identified the application environment. So you have to be making reference to these 3 cycles as you're answering the question. Don't just answer the question directly. Say, okay, the problem I will design a software, the software with this and that, without reference to this cycle. So if you are talking about the software as an artifact, as an instantiation, so you have to begin by saying, like, having studied like the people, the environment, the technical, the environment, and having identified this problem, we came up with idea that this problem is very relevant because it pertains to some technological problems that are having, which I think a software artifact could solve. So you demonstrate that this problem, and in order to understand this problem better, I used PFAS 7 steps, and then applied the Hefner and Chatterjee checklist, of evaluating an artifact. Then in the building and evaluation phase, understand, so we're able to, you mentioned Canet theories, found exist Canet theories that explains, that gives you an inspiration on what you are going to do. And then mention like,
what if you don't have like you said, what if you don't have a kernel theory for the question they're given?
Even if they don't mention a kernel theory, you have to mention it.
Okay, so not something specific. You just say generally work with the kernel theory. Okay.
Yes.
Okay.
You are going to mention it. That's what I'm saying. Every answer you are going to, provide will revolve around this cycle.
Okay.
Yeah, there's no way, even if the question didn't ask you, because during our own time, we were asked, the first question was, what is kernel theory? And how does kernel theory contribute to an artifact design? So we have that kind of a specific question. But still, in answering the question, in proposing a solution, maybe an instantiation, you have to still mention that this is one thing tricky about qualifying exams. Sometimes people presume, because of the nature of the problem, you simply presume. The qualifying exam is meant to test your knowledge of if you know what to do when you are faced with this problem, because you are not solving the actual problem within the exam. So, but they want you to mention that you will need a kernel theory that provide insight or some prescriptive, information on how to design this artifact. You have to mention it just to show that you know what should be done. Not because that you will apply it in that exam, or you have to actually waste all your time trying to find which theory will be relevant to the solution you are offering on the day of exam. No, just to mention it. So by mentioning it, it shows that, okay, yeah, he knows the right, he know what should be done, So that's why I asked you to mention it. So plug in everything into this cycle. So which means all your solution will revolve around this cycle. You have to mention the relevance, the design cycle, and then the rigor. Mention it, and then usually what I do is each paragraph for relevance, another paragraph, the design cycle, where I discuss evaluation and the metrics and everything, and then the knowledge base, the kind of contribution that the software will make, kind of projected contribution it is going to make, and whatever principles or kernel theories that inform the design, to mention them. So that's why, look at the checklist. Memorize this checklist. Anything I ask you to memorize here, please pay attention to it. I ask you to memorize this. I've gone through this thing more than 40 or 50 times. So I have a picture of this in my mind. You must memorize all these people, organizational, but don't forget the environment. Then the design and evaluation phase, design cycle, the knowledge base. It is easier for you to picture it in your mind, so that when you are answering your question, your mind will be iterating between these different cycles. So please pay more attention and memorize it, so that when you are answering the question, you are plugging it in. This checklist, memorize it. Make sure that your answers covers every aspect of this checklist. What is the research question? Sometimes the question itself on the day of exam gives you the research question. What is the artifact? How is the artifact represented? These are the two important things. There are two important things I need to mention very fast. When you're talking about an artifact, you first of all think about the form and the function. The form is how is it going to be represented. The function is what are the specific features of this artifact, and what are these features going to provide to the stakeholder. So don't forget to mention the artifact form and function. Don't just say, I'm going to design an artifact that we do this and that. What is the artifact? How is it represented? Is it an algorithm? Is it a software? Is it a framework? Is it a model? Tell us how the artifact will be represented. Don't fail to mention that. That is the form. Don't fail to mention the features of the artifact. These are the things. DSR was one of the most challenging for me during the qual. In the other exam, in the other papers, I was able to reflect a bit and then started writing. But I spend more time in DSR because it's a wicked problem. Then it was, they say that many people are resisting taking the COVID vaccine. How can you design an artifact that will, encourage people to adopt, an artifact that will assuage, their fears for the COVID vaccine? Imagine that kind of thing. So I was, what kind of, it's always the way of software. So maybe I'm gonna do with a software that can be downloaded, in an app, mention it's Android or OS, and this app is going to interface with the CDCI, and then, and then people can check this app will give people information about their health status and about what is happening around them, whether there are chances they are going to get the virus, whether there are people around them who are going to get the virus. I begin to list like features of what this apps is going to provide. First of all, people can check their health records. It will record, it will show location, all this stuff, So I have to provide like some features of it, come up with something fast. So you're gonna take more time to really launch yourself, into writing, having identified the form of the artifact. Then the features will take you a little time because you are mentioning them and then you are explaining. And at the same time, you have the cycle in mind, and then this checklist. So how is it going to be represented? That is the form. What design processes, such heuristics will be used to build the artifact? Design processes, usually from the knowledge base or from theories, kernel theories, So there could be processes, that could be existing design processes out there, that you can borrow the idea to do this. So there could be some heuristics. One of the heuristics I don't remember, when we are doing system engineering, is that the greatest problems we encounter in system design is usually at the interfaces. Understand? So that's a design heuristic. The problem is usually at the interfaces. So you might say, because your artifact might have an interface, so you have to improve the interfacing so that it becomes like seamless in connection, So that kind of heuristics. So it could be another heuristic, could be any other principles of the design principles out there that you can, that is useful in the building of the artifact. If you're a software person, understand. If you are a software person and then you know about agile software development, understand, the importance of consulting the customer. So All these things could also be interacting with the customer to specify, the system requirements. All these things are heuristics. Mention them. And then, okay, do you want to ask a question?
No.
So how are the artifacts and the design process is grounded in the knowledge base? What any theories to support the artifact design and design process? So that's what we're talking about. Grounded in the knowledge base, theories, have to mention kind of theories, whether you have one or not, just mention it. What evaluations are going to be performed during the internal design cycles? What design improvements are identified during each design cycle? Evaluations. Is it going to be social, technical, or just technical? And what are the improvements you observed for each evaluation you did? So if you did multiple evaluation, you have to state the improvements. So how is the artifact introduced into the application environment, and how is the field tested? What metrics are used to demonstrate the utility, which is related to the evaluation, the metrics? And how is it going to be introduced? How are people going to use it? Like I mentioned earlier, it is going to be an app. People are going to download, that stuff, that kind of, So what new knowledge is added to the knowledge base, from peer review, literature, meta artifact, new theory, and then, so you can come up with something that maybe with you believe it's kind of a proposition. Believe that the artifacts, would contribute in encouraging people, to do this or to do this better. So, and then maybe if there is a broad theory, maybe like I mentioned, human resource management, it will kind of be an additional improvement to human resource management if it is related to that. So has the research question been satisfactorily addressed? And that's left for you, So you have to mention most of these things. So though some of them, like, has the research question been satisfactorily addressed, may not be, practical to answer it in the exam, but you also mention things like maybe you hope that this artifact will also solve the problem, that you proposed. So yeah, any questions so far? So this checklist, have it in mind and make sure that the artifact, covers every aspect of this checklist. Very necessary. Still, this is the cycle again, helping you to understand it better and even more better. Who can explain the meaning of these numbers? You see, these numbers are not chronologically placed on this chart, but their positioning means a lot.
Are they corresponding to the questions that we just went over?
Part of it, yes. Is the cycle is also grounded on the checklist. But if you can make sense of these numbers, then you have understood everything about this cycle. Who wants to try? It could be complicated looking at it, but if you're able to resolve this puzzle about these numbers.
And so, I mean, it follows in the previous slides, right? You have the arrows that showed the various cycles. The way I see this is the first step you do would be you gather sort of requirements from the environment, which informs your design or your research, your DSR research. I don't know, from two, you once you get that input,
I just showed you,
so
two.
yeah, so Amrit was right now, right? It's following the checklist.
Yeah.
But the idea behind is that it's an iterative process. So like you're starting here, jumping into here, going into here, going back and forth. It's an iterative process design, and that's what you have to understand.
Yeah. So the two,
could you keep
the artifact form, So 3 are there like heuristics and other, principles, so that forms the design. And then look at where is 4. 4 has to do with, how the artifact process is grounded in the knowledge base. Theories to support the design. That is 4 from the, from the knowledge base grounding. Then the 5, evaluation are performed during the internal. So is there any evaluation? And the evaluation is here. And then 6, in application environment and how is it field tested? 6 in the application environment, how is field tested? Then 7, what is it added to the knowledge base? Look at it, 7, added to the knowledge base. And the 8, did you solve the problem? Simple. So we see iterative, so that's why I'm saying memorize these two. Memorize.
Is there an example for it?
What?
Is there an example?
An example?
Yeah, so like apply all these 8 steps.
An example. You say you are building a software. You need a software that manages tracks people's health.
Yeah, Bernard mentioned for your own, you had the COVID test.
COVID stuff. Understand? Yes. First of all, propose that it's going to be identified the problem already. 1, 2, the artifact form is going to be a software. 3, there are some processes or heuristics that can be informed based on maybe earlier design, or you're doing an improvement. If it is, since it is not already there, look at some of the processes or things that can inform, your design. Then 4 says, okay, you take something from the knowledge base, if there is any, then 5, look at how you're going to evaluate if it works for the people, the metrics. And the metrics I use then for my COVID is, one of the metrics I propose, first of all, usability. I measured usability. That was a first for me. Usability to, we are people able to actually use the software, So it's going to be, I said, I'm going to provide like a field survey, post a survey online and people can answer, people who have downloaded the app. So it was that's one of the evaluations I mentioned. And then with the predictive accuracy of the app, does it really track, the health? If someone should go to the hospital and check the health vital signs, does it correspond with what you get in the app? I also mentioned like a notification. And notification, is it accurate? Is the timing in the app accurate? So all these things to demonstrate that it really works. Then will it encourage people, to? It is really a wicked problem. So at the end, you are going to mention all these things, but in actual practice, you don't even know if it's going to solve the real problem. But this is like for you to give an idea of how things might work, So the eighth one is like, have you answered? You were able to solve the problem? Have you answered the research question? So find anything you can think of, about solving a problem works with this cycle. Whether existing problems you want to improve or like a new one, a new and a unique problem you want to address, they are going to fall somewhere within this cycle.
Sorry, who came up with the cycle? Was it Hefner?
Chatterjee checklist have this. This cycle, DSR cycle, I think Chatterjee and Hefner and the rest must have contributed to this.
Okay.
There was no credit to, because that would be a collective work of, it has undergone a lot of improvements over the years from when it was first published, I think with Hefner and Chatterjee. Look at applying the framework now. So at this like answers the question, in a very clearer way. Now we are applying them. What are they trying to solve? Clinicians, patients and researchers, patient readmission monitoring. So the people here is clinicians. The organization is EMR. What is the full meaning of EMR? Electronic management record, right? and then the technical system admission, So the problem here,
electronic medical record, though.
electronic medical record, yeah. So I know that this is your area, Mohammed.
Yeah.
So this will be very clear to you. So the problem is readmission. The opportunities, patterns of readmission. Now you see the relevance cycle, the clinician, LLU and CGU, existing LLU system, readmission, patient readmission monitoring. So they were able to identify, all the environment and the people involved, and then what is why the problem is actually relevant. And then look at the artifact design. So alternative design, supervised learning, predictive model evaluation, model validation. So this is mostly like evaluation of this particular artifact and its representation.
The artifact here was a model.
Yeah. So yeah, because it said it's a framework. Okay, applying this framework. So it's a model validation. So
the form of the artifact here is a model.
Yes, model. A model predicting patterns of readmission.
Okay.
Yeah. So, and these are the other evaluation that goes into the model.
Yeah, the activities.
Then the knowledge base. The knowledge base is the theories, the DSR, experience, and expertise, product and processes. So the readmission risk score, the design science research, the data mining methods, and the readmission prediction. So this is for people in healthcare. Mohammed, I think this makes more sensible, very sensible to you. So they use data mining here. They use readmission prediction and then readmission risk score. Okay, Amrik, you shared something. Trey.
I would just try to figure out who came up with the 3. It says Hefner in a publication in 2017 came up with the 3-cycle view DSR.
Okay, Hefner. Yeah, I know that's related to Hefner. Hefner was with us, last semester when the DSR, right? Okay, right?
Yeah.
No.
Yeah. Wow.
He came to talk to the class when we were in the class.
Oh yeah, Hefner.
Okay. So Chatterjee taught you Amrik, right?
Yeah.
Okay. Yeah. Hefner didn't come to our class.
He came.
Chatterjee also taught me, So.
Okay. Did you take the class or you are new to it?
No, I took the class.
Okay. Get to the class already. So.
But for the I don't know, because we had Hmong, but the qualifying is going to be Chatterjee, who's going to I don't know, write the question.
Yeah. He said the questions. Yeah, he will be the one to handle the question. Look at the last set that took the exam. It was, I wish I was with them. You see, there is some kind of inconsistencies the way they say this question. There are some years that are harder. There are some years that are more simpler. This last set was far the simplest year I've ever seen.
Wow.
Yeah, their questions were very precise. A, B, C, so that you know which one you are answering, and very clear and straight to the point. Unlike our own, they will try to provide, give a detailed description of each question, like in 3-4 lines, and then place, 50 mark at the end. You don't even know when you have
what you have answered.
when you have answered one and when you have gone to the other one. But this one, like A, B, C, D. You were able to know, I finished this one, I've gone over to this one, but during our own time. The worst one is the spring 2021.
You know why I think that is? Because the semester prior, a lot of people failed.
Yes.
And so they tried to make it a little bit more clear. And maybe, I don't know if I'd say easy, but clear for the people that failed it the semester before. I think that's why they did it. Because I was looking through it and I was like, man, this one, I should have taken it. I knew every single question.
Yeah, and still, some people still failed it again,
Yeah.
So, and we are not very sure how it's going to be this time around, because
it's going to be
beautiful.
It's
like they dropped 501. You know, 500, 501. It looks like they dropped it.
Yeah.
Oh, really?
Yeah.
So prior, they used to have 5 categories, including 501. Now you only have 4. Go to your mom.
Yeah. I don't know how they're going to go about it, but that 501 is still very foundational, you know, to your understanding the rest of what we are doing.
So are you saying that this time around they're not going to ask 501 questions?
I'm not very sure, but you know, it's not there for the syllabus we saw.
In the email that was sent out today, it says day 1 questions will be 501, 503, 504. Day 2 will be 505 and integrated
again, yeah. Let me.
So if you go what to expect on the day from FF.
Yeah, let me share the email.
Yeah.
But
up here, it doesn't have 501. I think it's just an error.
Okay, I was thinking
because the questions say that there's going to be 501
email today.
Yeah, there was an email sent on the, I think it was today.
Look at it here. So
yeah. So if you scroll down to the questions, it says what questions will be what day.
You see?
Yeah.
Oh. Amrik, have you registered for it?
Have I registered for it?
Yeah.
Yeah, I don't have a choice. I had to.
What is it? What is it? Because I haven't registered. What is the deadline to register?
May 15th.
Okay.
I think that's what it says. Yeah, fall quarter registration closed May 15th. So, but oh yeah. So yeah, if you look at in the email, it says what questions on day. It says 501, 503, 504 is on day 1. I think on the top one they just forgot to mention 501.
Yeah. So what day?
Yeah. Wait. It's this. Wait. What? Wait. Go back.
Yeah. Yeah. So.
Yeah. So 501.
503, 504.
I don't think.
So if you already registered for the exam, right?
I'm already registered. Yeah.
Okay. What are you waiting for? You're not yet ready.
No. I'll get ready. It's just I haven't had time to register, but hopefully between now and next week I'll just try and do this stuff.
Yeah. Usually, it's not very easy decision to make when people consider a lot of things around them. Considering the fact that you have only 2 chances, so people want to, take the exams when they think they have the best opportunity and the time to take it, because it's really a hard decision. I can see you even not doing it in the next 2 weeks.
The exam is like the death. You have to face it, man.
Yeah, you have to face it. That's what I tell guys. Just put it there. Register it, and if you cancel it, I don't know when cancel it. There's a time you will cancel it, and then it is taken that you have already taken the exams. So and then,
yeah.
Don't worry, there are worse things in life. Oh man.
So let me get back to my screen.
So in these sessions, do we go through past questions, or is just like
what we are doing now is more important. What we are doing now is more important. It's a kind of a refresher.
Okay.
Yeah. When you get the past questions, you begin to apply most of these things. If you don't know most of these things, there is no way you can answer the past questions.
Yeah. So I just want to get a feel. Do they repeat questions?
Yeah. So that's why we make references to.
They repeat questions, right?
Huh?
Do they repeat questions over the last?
Not so much. Not so much. They don't but there are some questions like issues about theory, will always be there in one form or the other. They don't repeat in the strict sense of repeating questions. They don't.
Okay.
In the strict sense, they don't. But there are, it is the same IS courses. So it is the same things you already know, but it comes in different ways. The questions come in confusing, very confusing ways. It was on the day of exam that I during the 504 that I first had causal and non-causal. I didn't hear it throughout the entire period of preparation, but I was able to figure it out. You know, I think.
What is 504 again? Is that quant?
Yeah, quantitative. Yeah. So I was able to figure out what is a causal and a non-causal research design. Do you know about it?
I can't recall, man. I don't know. I don't think I've heard about it.
Oh yeah, that's it. So all these things are like still trying to understand how we understand the problem better. I'm looking for the papers. There are a lot of models out there. All these models are, to help you to understand the problem better. Problem definition and you don't need all these things. You don't need to memorize these ones. I've told you the most important ones. Finding problems. Look at where you find problems. Attending meetings, and then this is all over. So 2 sections covered. Let me go to the 3rd section, to the 3rd model. So you see how we're progressing. We are faster because we have all taken this class, and then we know most of these things already. Conceptual models for design thinking. Honestly, let me tell you, we have already covered everything you need to know about this course. So the conceptual models. These are some of the models that help you to. Usually, every design begins with some level of conceptualization or initial ideation of how the problem is going to be. So most of these models are meant to help you to organize your thoughts to be more focused, with the design languages and the model fit, mental model, and the conceptual model fit. And you know about this mental model, the way you describe things, must be meaningful when it comes to the actual practice, like the system display. And there has to be a fit between what people usually think, and how it should be done in practice. In system engineering, they talk about the intuitive design. Intuitive design. Usually, you put it on the switch, it is on, put it down, off. So like it has become intuitive almost for people to, so if you like to come up with a design that is contrary to the mental model of what people think the way, like you're opening a door, you should be pushing out, and when you're closing, you're pushing back. If you redesign a door that you need to open by, it's against the mental model. So this model fit has to be there in wherever you are designing a system. So all these things, human layer, the software layer, and the platform layer. These are the depths of, like, if you're building a system, can be defined generally as a collection of elements of work together, the components. So the human, the software, and the platform. Trends. So these are some deeper details. Design is achieving goals within constraints. There is always a trade-off. Constraints could be material, standard cost, time, health and safety, trade-offs involving goals, constraints, and for others, mate. Human and computer interaction. And this is a human person. Here, like I mentioned before, the rest of the IX, like the qualitative and the quantitative approaches we use trying to understand this human person here, his behavioral patterns, in using the system. And then here's the system, the technical aspects, where it has to do with the computer itself. Look at the interaction. At the middle is where we do our tinkering. I remember this terminology, theoretical tinkering. So DSR is not theoretical tinkering.
Theoretical. Oh my goodness.
And that is with reference to kernel theories. Understand?
Yeah, it was that other guy that came up with it. What's his name?
That was Monk. Is it not Monk that said it?
Monk said it, but it was his friend that came to give the presentation who first used it in that one paper. if you're the other guy, I think one of the first guest speakers after Chatterjee.
Yeah.
Oh yeah. A theoretical thinker.
Yeah, theoretical, theoretical thinking. That's philosophical, highly philosophical. People who like to mesmerize people with their language. This is the kind of thing they say it.
Yeah, this is what they look for. This is the academic, the something rigor, whatever it is. The rigor, the theoretical rigor that they always want to try and have.
Yes, it's in relation, to that theoretical rigor. So it is not theoretical, without. So you are thinking within the framework of a theory, So the theory has to guide your thinking. A theory has to guide your be an inspiration to what you are doing.
Yeah,
so there's always a reference to theory. So it is not theoretical thinking. So this is where you can find this whole interface of the human-computer interaction: engineering, design, sociology, ethnography, cognitive space. All these things like you can inform the design of an artifact. You can find problem, in these different areas. So the future of HCI, the golden rule: understanding your materials, but design produced may be different for it. Understanding people, psychologist, aspect of human error.
Sorry, are all these in Chatterjee's book? The book he wrote?
Yeah, these are slides. Yeah, usability is defined from the start.
No. I'm saying, Chatterjee has a book.
Yes.
Are these slides from that book?
Yeah, almost like every of these slides are also from the book.
Okay.
Yeah. He co-authored the book with forgotten the person. Don't know whether it's even.
Moto G stylus 5G.
Yeah, he co-authored the book. Oh, this is already. We should be taking a regression and going on break. So, guys, let's stop here because it's already 8:40. So we take almost like we come back at 9 o'clock. But usually I always hang around if we have other things to discuss. So we have to pause here and then stretch our legs, and then we continue at 9. Hey, we can talk about other things. Hey, $44 billion on Twitter.
Hey, you want to pause the recording?
Oh, yeah. Thank you for reminding me. I almost forgot.
God save the Queen. 43, 44. Yep.
Yeah.
He wants to save free speech. It's not so bad. Not so bad.
Oh my God, Elon will buy the whole of US someday.
You're still recording though.
Still recording?
Yeah.
No, I thought I've already.
We got like for statistical book, it's called Andy Field. He's a British prof, and this is a new book. And also we got Steven Pinker and for reasoning, and also we got J&J. Did you study Gigardo and Jacobi or no?
No.
In 504, we only had the PLS book and the statistics book by the guy that you just mentioned.
Yeah, we didn't study the Jacquard and Jacobi. Their name is funny.
Yeah.
Jacquard and Jacobi.
Yeah, but it's really good though. It's like this book, like if you understand what is like the theory is, that will give you it will expand your knowledge. It's a really good book, the J&J. And also even he talk about the Koba, the theory. Yeah, I talk everything about everything.
Yeah, let's continue.
And also, and also sorry, Emerick, we got also another book for the PLS is version 2021, the third edition. This is also a new book.
Oh, okay. I'll have to check out the syllabus online, see if they have it posted.
Yeah, I'll have to update it later. So get to know the user. I think this already is covered, earlier on in our discussion about the application environment. Get to know the people, and then what's the problem? Know they are probably not like you. Talk to them. Open-ended discussions. And the importance is just to understand what they actually they need. So what is design thinking? Design thinking is a methodology used by designers to solve complex problems and find desirable solutions. Logic, imagination, intuition, systematic reasoning, possibilities of words. A design mindset is not problem focused, it is solution focused, action oriented, a design mindset. So a framework for creativity and innovation. All these things are design, build, adapt. Design is a set of distributed activities of different kinds by different people and different times. Design of emerging digital taxonomy is like a taxonomy they created, by Professor Chatterjee and whoever. Digital services, just like an example of oh, why is I'm sharing something but it's no longer moving? Why? What happened? Resume share. Oh, I paused the sharing, sorry. So
Clement,
yes,
I don't see any material for 505 in the shared folder, because you mentioned earlier today in the WhatsApp that you have shared something. Did you delete that?
I mentioned in the WhatsApp that I shared something on WhatsApp. That's what I said.
Yeah. I know. I read your questions on WhatsApp, but I mean, you shared material. You mentioned that you shared material in the shared folder.
I didn't mention shared folder. I said I'll try to read what I shared. I shared something here on WhatsApp. I didn't make reference to the shared folder. I didn't add anything. There's nothing to be added to the shared folder. Like what I'm sharing is from Chatterjee's slides. So this is, we just finished model 3. The model 4 is design and innovation method. Design theory. Model 5 should be.
What are the slides from the time you took the class?
Yes.
Oh, okay. Still available on Canvas?
Yeah, they're always available there. After you take any class, you still have them.
Okay.
Yeah.
Yeah, I don't have them. No.
You will get your own when you take the class.
Mohammed, calm down.
Like basically, you guys, you're telling me you have to pay to get them.
Calm down.
Well, yeah.
What's going on? You don't want to take the class? You want to take the tutorial? You don't want to pay the school fees? What's going on? Calm down.
No, well, it's helped me like get prepared, be ahead of the game. But
that's good.
Yeah, it's preparing ahead of time.
Well, do you have an idea of what your dissertation would be on, Mohammed?
Yeah. Well, it's one of two. Actually, one of the three. Either security, like pure security, or pure healthcare, or security in healthcare.
Okay, cool.
Yeah, that's what I'm deciding. What about you?
Oh, it's and Clement knows this. It's elderly, basically geriatric research, specifically with fall risk assessment with the elderly people.
Oh, nice. This is also healthcare.
Yeah, healthcare. So I did. I'm sorry, Clement, if we have hijacked this session, but very quickly, Mohammed, I did for this design thing. I worked on during my project for this design class. I worked on sort of electronic healthcare records using the blockchain. So that is I mean, that's a security metric. So it might be something that you might be interested in looking at too.
Yeah, let's keep in touch though.
All
Maybe
right.
we like do some paper in the future.
Okay, cool.
Yeah.
Sorry, Clement.
So,
I'll get back to you. Yeah.
It says here, natural science and socio-human sciences have many theories, but applied fields often like the IT, are lacking much theory. IT, marketing, medicine, we have because of the most of these we have a kind of practical-oriented paradigm. So, and then they focus on solving problems that are very contextual. So that's why it is difficult to have any kind of grand theories in design science. We don't have a design science there, grand theory. So a theory is a coherent description. So this particular area now we are looking at now is trying to launch us into understanding, basically the same things we have already known about, theories. Because there's so much.
Clement, I have a question.
Yeah.
When I was doing this design course, right? One of my, I think either the exam or the paper, the project, I proposed a grand theory based on what I was working on. So you know how the exam with the Hmong was that paper he gave and said people should write things about the paper. The grand theory I proposed was, if you have a reliable system, people will be more inclined to trust and use the system. Is that a grand theory?
It can never be a grand theory. It's just an assertion, an educated guess. Yeah, it's an educated guess. It's a kind of a hypothetical proposition. It's not a grand. Before something becomes a grand theory, you must define the scope. You must define the phenomenon. You have to use data, text it, and it has to stand the test of time. Refutation from many researchers. You don't just come up. You must state the scope. You must have done a lot of data collection and analysis, using different systems in different organizations, so triangulation time, so it takes a lot to build a grand theory. So it takes a lot. So
it's only in design research that it was never mentioned design theory. All the other quant, nobody talks about grand theory. It's only in design.
Making a contribution to knowledge in DSR in terms of no, in other courses, in other areas, you can actually come up with a theory. We do build theory deductively and inductively, So we also build theories, we develop theories, we test theories using the qualitative and quantitative, So, but here
that's what I'm saying. Can't I build a theory deductively in DSR based on my research?
If you wanna do a theory deductively, which means you are moving from a general assertion to a particular conclusion, it has to be tested. That's what we're going to see, how to build these theories. You have to collect actual data. Like what you did now is a hypothetical statement you made, but it has to be within the context of a theory. And then you are using a construct of this theory, as a hypothesis to answer what you just said. So you're going to collect data to test if it is true. So that means you are building deductively, So you're taking already a construct from a theory. That is a hypothetical deductive method. You have to establish a theory that says what you just mentioned, or you just collect data inductively and begin to look at what comes out of your data, So still based on some existing theories. So we have kernel theories. Kernel theories are usually reference theories. They are grand theories. Why are they called kernel? Who knows why it is called kernel? kernel theories. You know why they are called kernel theories?
I always thought, I don't honestly know, but I always thought about kernel as like usually the core of the computer. And that's like the kernel. So the kernel theory is like the base is underneath and then you build on the top.
Yeah, these are usually theories from the natural, and the social sciences. Mostly we have a lot of them in natural sciences. These are theories from behavioral sciences. We have a lot of them from psychology. And the IS has borrowed so much from psychology, this predictive model, the Utah, they're basically the term 1, 2, 3, they're all deeply rooted in psychological constructs to explain human behavior. And they are called kernel because they are grand theories that are very parsimonious. Parsimonious, they have lower, lesser predictions, and they cover, every data that falls within the scope of that theory it provides a clearer explanation, So when you are working with these kind of theories, you know that these are time-tested theories. Time-tested theories. Theories that have attempted withstand several refutations, and they can explain phenomenon in a very parsimonious way, clearer way, distinct way. Other things like what I shared in the WhatsApp when it comes to theories, you can apply it to this now. So let me look at it again. So there are things to evaluate theories. Okay. Let me look at it. Yeah, you have to look at a theory should be understandable. They are very understandable. They have high clarity. They are very parsimonious. They have comprehensiveness. They make capable. They can be empirically validated and verifiable. So all these things that goes into like a kind of theory, that reference theory. So carrying out the actual research work and then the output stage, you always begin with these kind of theories, and these theories provide a lens to whatever research you are carrying out. Whether you are doing qualitative, quantitative, if you're also doing design science research, the artifact has to embody, theoretical constructs. And then the output will be theory, could be principles, could be law, could be design theory, could be design principles, could also be some kind of law. So theory building is messy. I usually begin by observing phenomenon, and then understand patterns of interaction and reaction goes on there. So we have 3 types of theories: local theories, a mid-range, and a grand. These ones have the widest boundaries. The mid-range are more specific grand theory. They tend to be explaining relationship. Maybe they are is this predicting outcomes within a bounded domain. Bounded domain, They do not establish general laws. They have some degree of generalizability or transferability of what is learned from the theory building. So the local theories, some of the theories we have in IIS are mostly, in the kind of theories we can produce in DSR are like local theories. We can't have any grounded theory in there because it is contextual. So I don't know, maybe someday in the future, but for now, there are no grand theory, not even mid-range. So we have local theories. So any kind of grand DSR theory now, will be like local theories, and specifically titled coupled to the context. And then problem of generalization also comes in DSR. I remember I asked Chatterjee this question: can we also generalize? Yes, you can also generalize within a specific domain, problem solution space. So if it is like in human resource management, you develop, design the artifact, you can generalize it, provide a similar solution within that same solution space or the problem domain. It doesn't go beyond that. So if it is electronic health management record, it is still within that context. You can't take it to other aspect of the medical practice.
So what you're saying that it doesn't generalize, like a local theory cannot generalize into a mid-range theory. Is that what you're saying?
What I'm trying to say that local theory, that most of the theories we have in DSR are local theories. That is, they are tightly bound to the context. So we talk about generalization, they can only generalize to specific context, like in qualitative research. You know, if it's like you worked on health management record, electronic health management record, so it's going to be within the same. You can, even if you worked, evaluated the artifact within one hospital, you can apply it to other hospitals within that same context, within the same problem domain and the solution space.
Well, my point is that even though you generalize a local theory, right?
Yes.
It will still remain local.
It will still remain local, yeah, because there's no way you can solve a problem for outpatient department and take it to emergency ward. It doesn't, you know, yeah, it cannot work. So that's because of the, you know, this paradigm, you know, the problem paradigm and the contextual approach to solving problems in DSR. It actually makes it very difficult for you to come up with grand theories, you know, because of the nature of the approach itself. So look at what we have here. How to this applies to not just DSR. What we are looking at now, it applies to theory building in general in IX. Everything in my theory. That's why all these things are like
overlapping.
Yeah, they overlap. Yeah, so all the information overlaps. So whatever you learn here, you can take to other IS courses. So how to build theory, deductive and inductive. So deductive, usually what we do mostly, like in quantitative, is deductive. That is confirmatory theory texting. When you are doing confirmatory theory texting, you are taking the deductive approach. And usually you begin with a theory.
Did you say quantitative?
Yeah, you build it with a theoretical construct, deductive. Yeah, you are moving from a general conclusion to a particular, you know, from a general proposition to a particular conclusion. Yeah.
Okay, and you said that is done in qualitative?
No, the same in quantitative.
Quantitative.
Confirmatory theory texting, you know, it's always deductive approach.
Okay.
Yeah, because you begin with a theoretical constructs, and then you raise hypothetical, you know, questions, you know, predictions on the grounds of that theory, and then you text your hypothesis, you know. So it's always deductive. So which means a theory have already established a general conclusion, and then based on the general conclusion, you want to arrive, you know, to a particular based on the general claim of that theory, you want to text the claim in a particular domain, you know, so arriving at a particular conclusion. That is the deductive. So you also move in inductive. You also move from that particular conclusion again to establish another general principle. You know, move from the particular and then establish a more general principle. Move from general to particular, from particular to general. So that's what. And usually, when we usually begin by observation. Every theory building begins with an empirical observation, gathering data. When you observe, you begin to conceptualize. That is, you start building constructs. These constructs are explanations, you know, of different aspects of the phenomenon you are trying to study. And then you begin to operationalize, turn these constructs into measurable, you know, and into quantifiable, using maybe some metrics to quantify and measure these constructs. And this is a very important when you're evaluating any model, you know, in IS, any paper, you know, this comes into play. The conceptual, and I went through this, and if I share my pre-dissertation proposal, which I submitted to professor, you will see what I was doing, you know. I tried to, you want me to conceptualize what is the meaning of these constructs. Like in UTAUT, they'll say performance expectancy means, you know, that the perception of the user that the system will contribute to doing his job better. You know, so there has to be what does this construct mean? It's different from a dictionary meaning. Understand? A dictionary can establish general meaning for, but usually in research, they will tell you to, so for the purposes of this research, we have to understand the power as so, and so, so that you understand what this actually means within the context of the research, So operationalize how it will be measured, which means the conceptualization and operationalization, they overlap. That means you have to describe the phenomenon in measurable terms, in such a way that it can actually be measured. And there is, if you look at the UTAUT, they have 4 scales for measuring performance expectancy. And then when you do this, you confirm, and then apply. The confirmation is to ensure that what you observed and then what you measured is actually what you should be measuring. Like usually we talk about construct validity and the content validity. You confirm that the relationship are actually there, and then you apply it, to solving a problem. And they continue to refine iteratively, So these are observed, the observed and experienced world. That is the whole world. Usually begin with your empirical observation and then conceptualize, and confirm, apply, and then refine, keep on refining. So theorizing, theory building process. You conceptualize, you operationalize, you apply, you confirm, and then you refine. Usually theory building goes through 2 stages, the descriptive and the normative stage. At the descriptive stage, let's say correlation. Correlation is just simple description. You talk about the relationship between the different variables. You don't go beyond that. In normative stages, that is when the theory will start to give you a more precise prediction about what is going on, telling you under these circumstances, this will be the result. That is when it goes to become a norm of action. So we're going to see it in the more detail. So building the descriptive process. Usually look at where it starts. You observe, you describe, you measure the phenomenon. That's where you have the constructs, conceptualize and operationalize. And then the second stage is begin to categorize based upon attributes of the phenomenon, framework and typologies. And then finally, you end up with models, a statement of association, usually the different constructs and how they are related, which ones are dependent and independent variables. That's the model you are going to come up with.
This is pretty useful.
Yeah, so deductive process, and also you move through inductive process. When there is anomalies encountered between the second level, then you go back again and then measure, describe again before you get to the model. So there can be an anomaly, maybe since there is something you didn't measure very well, something that is not very clear, something that doesn't fall in place. So you have to go back again and then remeasure again. Perhaps you don't have valid scales. You have to go back again and then measure again and ensure that you have construct and content validities are usually on this level of measurement, So if anything you measure up, if anything doesn't work well here, you can progress to this second level. And here is usually where you can encounter an anomaly, So it's always the deductive and the inductive, approach to building theories. So here you conceptualize and operationalize, and here you confirm. Confirmation, here you have a statement of association between the models, between the constructs that forms the model, So apply here, you apply, you conceptualize, you operationalize, and then you confirm. So the end, every theory begins with a kind of model of representation, kind of conceptual model of representing what goes. So every theory has a kind of model of representation. So distinction between theoretical and empirical construct. You have construct A, intelligence. I usually use intelligence all the time to explain, and this is a construct B, earning potential. What's the connection between intelligence and earning potential? This is independent variable. Intelligence is measured as IQ, so it's an independent variable. And then the earning potential is a construct dependent variable. starting salary. Or there could be a mediator here, maybe level of education, you know. So, but this like on a normal, simple explanation, usually here is the empirical plane. You make a proposition that intelligence will have a significant effect on earning potential. So that's your hypothetical prediction. And you want to text it. For you to text it, already you have operationalized intelligence. And intelligence can be measured through IQ. And this IQ involves a whole lot of things because there is not just a single measure. There has to be multi-item scales for measuring intelligence.
In this model, in this concept model, what does the arrow represent?
Which arrow?
These arrows, these blue arrows, do they represent like intelligence, affects IQ?
No. Look, okay, let me explain this diagram very well. At this level, you begin a theoretical plane, you conceptualize. You already have explained what intelligence means in your as a variable. You also explained what earning potential means as a variable. That is on the level of conceptualization. You have stated the meaning of intelligence in this study.
So
And
is intelligence construct A?
And the meaning of earning potential in this study. And then you also operationalize. Then on the second level now, so you having stated these two variables, and then what the meaning, the conceptual meaning of these two variables. Now you came up with a hypothetical statement that there is a relationship between intelligence and earning potential. Then the second plane now is where you operationalize the empirical plane. It has to do with collection of data to measure intelligence. And this intelligence, IQ is just one measure of intelligence, not just the only measure. So for the sake of like describing this, this is not the whole thing about intelligence. It's just like to give you an idea of how to conceptualize and operationalize. There could be multiple measures for intelligence. IQ score is just one. So IQ score is an independent variable. So this independent variable, IQ score, can be measured either through standardized testing, so you measure the independent variable, the IQ, through standardized testing, and then test the hypothesis, to know. And the dependent variable here is the earning potential, which is the certain salary. Then, based on your research, you could be able to find if there is any significant relationship. But what this second plane is describing is you operationalize, you measure, you measure the hypothesis by collecting data and then measuring these two variables. So that's it. A construct is an abstract concept, and a variable is a measurable representative of an abstract, Sometimes it is confusing, people say, we have latent variables. We have manifest variables. We have endogenous constructs, exogenous constructs, All this is sometimes can be confusing. Ask someone, what is a variable? For something to be a variable, for something to be a variable, it must really vary, which means it doesn't have one state. It can assume different states based on manipulations, based on changes, based on circumstances. It has to change. It's not something that assumes only one year. So it's always an abstract. It could be a variable, could be an abstract concept. An abstract concept that can be measured indirectly. And then we call it latent variable. That is like intelligence. It could also be something that is measurable directly, not abstract, not latent. It's manifest. Let's say, for instance, time or stock. Understand? You don't need to measure them indirectly. You can simply see the time there. You can simply see the stock there, So You measure them, like you can measure them with a one scale. One scale can just capture this, then you are stuck. You know already the closing balance and the opening balance. But intelligence, you can't measure intelligence directly. So therefore, you have to rely on variables, other variables to measure intelligence. And usually it is multi-scale. You have to use multi-scale to cover the entire domain of intelligence. If you use a single scale like IQ is not the only way of evaluating or measuring intelligence. There could be a whole lot of things involved, So look at this is a moderating, and look at intelligence, and look at see the moderate. What I said earlier. There could be a mediating variable, academic achievement, before you talk about earning potential.
Remind me what again a mediating variable does?
Yeah, look at mediating, So which means the strength of the earning potential, the actual amounts you make, depends on your academic achievement. Which means a mediator, can influence, positively, the relationship between these two constructs. It can make a significant contribution, a positive contribution. The strength of this relationship is determined so much by this mediating variable, And then here we have a moderator, So a moderator can increase or decrease the relationship between intelligence and so the more effort you put in, the more academic treatments you achieve. So the explanation here is that these are explained by independent mediating variables or intervening variables, and those that influence the relationship between the dependent and independent variables are called moderating variables, or moderate. So they affect the relationship. Those that are explained by the independent variables, while also explaining the dependent variables, are called mediating, while moderator, which is a moderator, increases the influence and the relationship between the dependent and the dependent variables. Defining relationships, outcome association, regression analysis, statistical. So all these things are very relevant in DSR because we mentioned during the evaluation phase, you can use most of these things comes to play, And normally it's identified when an outcome of which the theory cannot account. That is an opportunity to improve when theory occurs. That's when there is an anomaly. So other things like you already know from quantitative, anomaly and refining. Usually we refine when we gather more data again, and then test the data again to understand what's going on. Anomaly and refining. Transition to normative theory. Let me use this example is very, very important. So a study shows that there is a negative correlation between a student's anxiety before a test and the student's score on the test. But we cannot say that anxiety causes lower scores on the test. There could be other reasons. The student may not have studied well, for example. So the correlation here does not imply causation. However, consider the positive correlation between the number of hours spent in studying for a test and the grade you get. Here, there is a causation as well. If you spend more time studying, then it causes higher grade. So like this causal dimension is very important for developing a normative theory. So before a theory becomes normative, you must have understood the causal dimension. And that's what we do when we use regression and the other covariate-based or even PLSM to understand the mechanisms going on, to explain the causation, the causal dimension of the phenomenon we are studying. So without causation, you can't be able. So already the first one is purely descriptive. It's a correlation, which is pure description. There is test, there is an anxiety, but we can't say that anxiety contributed to poor grades. There is some other factor you need to understand. And that's essentially usually what we do in research. We try to understand these mechanisms that are at work. Sometimes they're hidden mechanisms, that are behind the observed effect. And that's why we use all this model, use experimentation to know where actually what is actually what's the factor responsible for what is going on. So once you understand that through the data, that's why you have to collect enough data so for you to be able to see if there is any effect actually, So once you have the causation there, you transit to the normative theory. So a theory completes the transition from descriptive to normative when it can give a manager unambiguous guidance about what actions will and will not lead to the desired results, given the circumstance in which she finds herself. So this is the same way we saw before. We observe, describe, and measure the phenomenon. We categorize, and then the model is a statement of causality. So you confirm, you predict, and then if there is an anomaly, you go back again, and then you confirm. So it goes on. Those were descriptive theory. The descriptive theory is still at the level of statement of relationship. Statement of relationship of what is going on. When it is confirmed, through data collection and the data analysis, deeper insight, when you unravel the causality, with the what is going on in the phenomenon, then you can actually arrive at a normative theory, So getting a normative theory could be very difficult. So most of the things we do, for you to conduct, maybe gather data in one company and say, oh, your research is, your hypothesis significant. That is not true. A second instance cannot confirm a theory, like what Papa said. You have to go through, because there could be some factors that you fail to account in your research. Maybe you conducted the research during rainy season and get certain results and get some statistical conclusion, significant statistical conclusion. That theory needs to be tested some other, maybe during the dry season again, or during winter or summer, or that kind of thing. You might need to triangulate the data with some subjects, like replication. So all these things is what we go through before you talk about normative theory, and then talk about the grand theory, okay, you were talking about. So it goes through a whole lot of processes, which you cannot just be able to accomplish in a single research.
It's proper falsification.
Yes. So this is a theory of a planned behavior. One of the theories that informed the Untitled model we're using today, perceived usefulness and actual usage. We already know this one. Some researchers will say that term is outdated.
Time is dead.
Yeah. Okay, look at Shelley Gregor, and where is design and action? That is where we are concentrating in design science. Says how to do something. A theory gives explicit prescriptions, method, techniques, principle, of form and function of constructing the artifact. So, but we also have that of analysis and explanation, and then prediction. What we have more in IX is explanation and prediction. This explanation and prediction. About mostly, let's say 70 or 80% of published articles are mostly on explanation and prediction in IX. Yeah, we don't do like single prediction or single explanation, theories. It's mostly explanation and prediction. Is there a design theory? The question is important. When DSL is considered as a method like quantitative and qualitative or mixed, then using design methods, how does one theorize? Well, one of the early design theories, okay, this is ISTD, one of the early design theories, because design theory is not possible, like some people would claim it's not possible, Kernel theories, meta requirement, meta designs, testable product hypothesis, kernel theories, and design method, testable design process, These are ISTD components of the theory, It's called, okay, I would call it a mid-range theory in IS. Their goal was to explain vigilant IS. They found this a very useful way to explain VIX. So it's like so we have a mid-range theory in IX. Mid-range theory, but not grand theory. Hooker design in practice. The notion of design theory is problematic because design like medicine or management is a practice, whereas chemistry or physics is defined by a set of phenomena it's assigned to study. So design is defined by what it's assigned to do. So it is not to dispute that one can theorize, not to dispute that one can theorize about design practice in the sense that one can theoretically understand the socio-psychological phenomena of design, but that is not design theory. It is Hooker, this is his own idea, you know. So Hooker maintains that there cannot be a theory of design. So the argument, Queen's indeterminacy. On the other hand, there can be supporting theories that is uniquely associated with practice. So this is like an ongoing debate, whether we can actually come up with a theory in design science. But yes, we have to maintain a positive attitude. When the phrase design theory is mentioned, what seems often to be meant is a kind of socio-psychological theory of the designing phenomenon. This can be of two types. One type investigates the process by which people actually generate design. What steps do designers generally follow? How did they learn the craft? Well, when several people produce the design, how do they interact? Once one can clearly build a theory around these questions, then but what would happen if people design differently? What factors, Criterion for goodness is defined in advance. So effort to formulate design or follow design hard to theorize. So theorizing in DSR fundamental question, does theory building method in natural science apply to the sciences of artificial? Do we need a completely different theorizing methodology? How can we make a theoretical contribution? Okay, an anatomy of a design theory. It must have a purpose and scope, construct, principle of form and function, artifact mutability, testable propositions, justificatory knowledge. Almost just the same thing that we find in a normal theory. Representation of entities, abstract blueprint of the architecture, changes in the state of artifact anticipated by the theory, true statement about design theory, and so look at it. I mentioned this thing earlier, the middle interaction. That is where we theorize. Theorizing in interaction and its effect, human-property interaction. So at the middle, here the domain proposed, source reference to the human, how humans behave, behavioral sciences, this area, psychology and the rest. And computer, how does the software computer work? Computational theory, system engineering theory, this area, system engineers and the computer scientists, software engineers and the rest. Here is the interaction, and this is where we theorize. So are you building theory or testing theory? So DSR researchers should position their theory in the middle, but how? So DSR scholars have maximum understanding of the design process, how the artifact works and how it behaves in the field. Extract and explain your design principles. Show with some thoughts of what impact this artifact has. Generalize. Start to think from an instance of a problem to a class of problems where your solution may apply. So that makes the knowledge contribution broader. So grand theory, level 2 theory, and then local. So extract and explain your design principles. Show this is how you can build a theory. Build a theory because you need the principles. You have to state the principles and the relationships. And then show some thought on the impact. Then generalize from an instance. What are design principles? Design principles are widely applicable laws, guidelines, biases, and design considerations which designers apply with discretion. Professionals from many disciplines, example, behavioral, sociology, physics, and agronomics, provide a foundation for design principles via their accumulated knowledge and experience. Keep it simple, stupid. This is a very heuristic, It's an example of a principle where you design for non-experts. So I mentioned all these things earlier already, about principles you can follow. So mobile compatibility principle, keeping in mind the ever-growing range of smartphone, tablets, and tablets must be effective for various screens, Mobile compatibility. Mobile compatibility is an issue. When I was designing my website, You know, sometimes after doing the website, I use what is the name of this software?
WordPress.
Elementor. I use Elementor. Yeah, sometimes after designing, it comes to your computer, it's very nice, goes to mobile, it is not good. So this compatibility issue is something, you know, work until I get it fixed. So these are some of the principles, like keep it stupid, you know, these are like design principles. So every artifact embodies these principles. And it is these principles that, you know, when evaluated and tested, can give rise to design theory. If you don't have, these principles usually falls within the rigor, you know, the rigor cycle of that framework, the rigor cycle. So the amount of principles that goes into the design, the theories that goes into design. So if you don't have a theory and you don't have all these principles guiding your design, you know, getting to the level of building a design theory might be difficult. The more the artifact is grounded in these principles, you know, the more you can come up with establish a theory.
Elementor is a part of is an application of WordPress. You mean for the websites, right?
For web, yeah, for web user interface. I did my website with the Elementor. Elementor is beautiful, very, very beautiful. One of the best for web design.
Yeah, it's the generic code of it is the WordPress, the content management system. So that they like Linux, you know, when they customize the version. So basically is a WordPress platform, and they customize it and they make it their own company, and they call it Elementor.
Yeah, it's a WordPress plugin. Yeah, you add it as a plugin and then use it. Yeah, very nice. So mid-range theory, expand the boundary of applicability to Simon's middle across a range of familiar problems. Activity theory also proposes a strong notion of mediation. All human experience is shaped by the tools and signs systems we use. Mediators connect us organically and intimately to the world. They are merely filters. Expand the boundary of applicability. Then grand theory towards a universal theory of design. So this is the Holy Grail and remains elusive today. So it remains elusive till this day. Grand theory. What theory is not? Theory is not reference. Theory data is not released. Variables are not. Concepts are not. Diagrams are not theory. Hypothesis is not theory. So this is over. So design theory. So
what time will stop today?
10. And it's almost 10. Yeah, maybe.
You have 6 minutes.
Yeah, we are going to continue with the evaluation next week, and I'm going to finish that next week, you know, with this DSR, and then we shall start looking at past questions. When it comes to past questions, you guys are going to decide each week. You decide, because this workshop will end this semester. Maybe before 11th or 18th of the semester, it will end. And once it ends, I sign off. My whatever CG you asked me to do must have been accomplished then. But before we finish, I will extend till maybe the 25 or 26. We will begin, like we might need to change our time for this meeting after this semester. Understand? We might need to change the timing. Maybe make it more 2 days. Make it when we are done with the semester. So when we're finished with DSR, we continue with evaluation next week. You know, so this is chapters 9 and 10, evaluation. Evaluation is a very, very interesting part of DSR. If you don't have good evaluation, then there's nothing. There's no way to demonstrate that the artifact works, and that means it means that nothing. In fact, the whole research endeavor is just a fruitless venture. You know, so we are going to continue with evaluation next Monday. By next Monday, we
So
complete with this. Huh?
Yeah, so the 505 exam, Clement, the final qualifying exam, is it how many questions they usually bring? Is it like heavy material because it has 1 day, 4 hours, right?
Yes. On the last day, you are going to do the integrative. Oh, Amrik is going. Good night, Amrik.
Okay, good night, Emmerich.
Next time.
Yeah, so I don't know the number of questions they are going to ask. I can, I don't know the number.
No, I mean, in your time, do you remember like what time, or how many questions you had?
It's up to 4 questions. Thank you, Amira. Good night. Bye-bye.
Bye, Amira. Good night.
And thank you. I'm sleeping here, so thank you so much.
Yeah, good night. Yeah,
You're
I
welcome.
can see you've already dozed off to the dreamland.
Yeah. All right, see you.
All right.
Bye.
Yeah, Mohammed.
Clement.
Yeah.
In your time, do you remember how many questions you got?
About 4 questions. About 4 questions for 504, right? For DSR.
Oh, it was like take 4 hours to solve it, or they are easy?
No. It's the integrative question and the design science, the 505. The 505 and the integrative question is the last day. So that's 4 hours or 3.5 hours. 3.5 hours is between the integrative question and the DSR.
Mm-hmm.
Yes.
So you cannot share those materials with me, right?
No, there's no way I can share them with you. It doesn't belong to me. It's in the canvas. I shared it from the canvas.
Oh,
I believe.
okay.
Yeah. But you can, when you watch these videos, you can pause and then read again from the videos. Yeah.
Okay.
All right. Take care.
Okay, got you.
Good night.
Okay, well, brother, thank you very much, and you have a good night, okay?
Yeah,
Bye.
good night.